Is there a faster algorithm for finding the longest common subsequence than O(m*n)? The longest common subsequence (LCS) problem is a classic challenge in computer science and a fundamental topic in algorithms that takes on significant roles in fields such as bioinformatics, genomics, and text processing. For those already familiar with this problem, the primary interest often lies in its time complexity, and whether there exist more efficient algorithms beyond the well-established O(m*n) complexity typically associated with the dynamic programming approach. The LCS problem. To briefly restate, the LCS problem involves finding the longest subsequence common to two sequences, which need not be contiguous in either sequence. This subsectional sequence should be present in both sequences in the same order. Dynamic programming approach. The dynamic programming method to solve the LCS problem involves creating a 2D table, often referred to as a dynamic table, where each cell at position i, j, contains the length of the longest common subsequence of the substrings up to the ith and jth elements of the two original sequences. This approach has a time complexity of O(m*n), where m and n are the lengths of the input sequences. Exploring faster algorithms. At present, the classic dynamic programming method remains one of the most efficient methods universally applicable for the LCS problem. For specific cases or under particular constraints, techniques such as Hirschberg's algorithm, which runs in O(n)m) time but uses less space, may come into play. However, in the general case and without further structural properties of the input sequences, achieving better than O(m)n) remains a theoretical challenge. This is largely because the LCS problem is rooted firmly in the combinatorial nature of sequences, requiring a thorough exploration of potential subsequences. Potential for improved complexity. The drive to find a faster algorithm with a reduced time complexity involves not only advances in theoretical computing but also in understanding the inherent limitations posed by the problem. While research continuously examines innovative strategies, breakthroughs may depend on novel techniques or complex mathematical structures that have yet to be developed. In conclusion, while the quest for faster solutions continues, the O(m*n) time complexity using dynamic programming is currently the standard method for solving the LCS problem efficiently. Future research and methods may provide alternative pathways, but as of this writing, no generally applicable technique surpasses this complexity for all input cases.